Hello, good morning, good afternoon, good evening from wherever you're watching this video from. Welcome back to our MPLS configuration series where the aim has been to configure MPLS L3VPN and L2VPN from scratch. This is our fourth video, meaning we have already done 3 videos, and if this is the first time joining us, please review the aforementioned videos before you can watch this one, just for consistency purposes. If again this is the first time joining us, on your screen is a very brief bio about myself so that you can get to know who I am and what I do. And I will be a trainer, and I have been a trainer for this particular series, and I will be a trainer until the end. So let's quickly go back to or do a recap of what we have done so far. So marked in green are the items we've covered or the things we've covered. We've already done step one and item 1 and item 2. So our focus today will be discussing about L3 VPN configuration. And just to take you to the next slide, this is what we will cover today. So I'm aiming to have this video under 40 minutes because the other 3 have been long. So I want to do my best and ensure that this video is under 40 minutes because we've already covered much of the stuff. We've laid down the ground. So we're just going to build up from where we left in video number 3. So our task today will be doing configuration of MPBGP between our provider edge routers. We only have 2 of them. And specifically, we'll be using or configuring MPBGP under the address family of VPN-v4 because we are dealing with IPv4, not IPv6. So that's why we will be using VPN-v4. If you're interested about VPN-v6, it's straightforward, almost the same concept. You could go ahead and do some personal studies on that. We will be covering that in this particular session or this particular MPLS configuration series. And then after doing MPBGP, we will go and create customer VRFs or VPN instances. And after that, we'll get to configure, because VRFs and VPN instances go hand in hand with route distinguishers and route targets. Then thereafter, we will switch to our customer and then configure the customer interfaces that connect to our CEs and put those ones under specific VRFs. And again, for our lab, we only have one VRF for L3VPN, so that will not be too much of a configuration to do. It will be a very simple thing. And then from there, now we can do the P to C routing, and our routing protocol of choice is BGP, just for simplicity. But you could go ahead and do SPF, ISIS, some even do static routing. But I would recommend you use BGP if possible or where necessary. And if you are at all, for some reasons, you are unable to use BGP, then you can choose either OSPF or ISIS. Just know that if you choose an IGP, you'll be able to do mutual redistribution. Okay, so having said that, let's get to the lab and enjoy this video. Okay, so I'm going to show you quickly again a recap. This is our topology that we have been using. We used this topology in our last video of MPLS basic configuration. We did just basic configuration of MPLS within our service provider environment, that is in green. We didn't touch on the CEs, and they were off, if you remember. But for this particular video, our CEs are now powered on and they are ready to go. So what is pre-configured for our CEs is the IP addresses and the host names. That's pre-configured. And as I mentioned, inside our service provider environment, I have already configured basic MPLS. And if I could quickly show you that. So in Rwanda PE01, which is a Huawei device, if we could issue the command display MPLS LSP. As you can see, we are getting labels assigned to our FECs, that is forward equivalent class, or you can just simply refer to these ones as prefixes, because you can see these are our loopback interfaces, and then these are our transport or the physical interfaces that connects the nodes. So looks like everything is fine here, and we can confirm the interfaces that are participating in MPLS, and as you can see, we have Ether trunk 15, that will be this logical interface here bundled together, and then interface this interface here is Ether trunk 17, sorry, and then 16. So we're done there. So let me quickly confirm, because our focus today will be on these 4 devices, this PE here and this PE here. So this is Huawei, this is Cisco, and then this CE here and this CE here. Those 4 devices are going to be our area of focus for today. So our aim or our main goal is to ensure that this particular CE12 connecting to Rwanda PE01 will be able to communicate with this CE14 connected to France PE01, PE08. As you can see, they are geographically separated. So for them to communicate to each other, they have to use our MPLS service provider infrastructure. And quickly, just to give you an overview of what we'll do, we'll just have to configure the customer VRF and then assign this particular interface to that VRF, and then assign this other particular interface to the customer VRF, and therefore thereafter, of course, after configuring MPBGP between this particular CEs using their loopbacks, and then we can now do the PE to CE pairing and see if we will be able to achieve our task. So I was confirming or verifying that MPLS is up and running. We've done that in Rwanda PE01. Let's quickly do the verification in France PE08, which is a Cisco device. Enable, then we can issue the command show MPLS interfaces, and as you can see again here, we have 3 interfaces that are participating in MPLS, or where we have enabled MPLS. We have the port channel, which is basically a bundle or an Ether trunk, but in Cisco ISXZ it's called a port channel 38, which is this particular connection here. And then now we have the 2 physical interfaces are standalone. There you go. And in our previous video we discussed why we are bundling them together and what we get, or the benefit of having physical links bundled together. So I'm not going to repeat. So quickly, let's verify that our CEs, which are Cisco devices, all of them are Cisco devices. Let's quickly verify that we have IP addresses configured, and we do 192.168.112.12 is this particular interface here, and the addressing space is simple to understand. The first 2 octet are 192.168, so this is a private IP, and then the third one is a combination of the device numbers, so 1 and 12, you get 112. Therefore, this particular interface will be .12. This one here will be .1. Yes, and then on this other end, we are doing 192.168.148.0/24. So 148 again is a combination of the device numbers, 148 to give you 148. So this will be .14. This will be .8. That's it. So we have confirmed that in CE12 we are good. Let's do CE14. Show IP interface brief. So we are getting to see that our interfaces have been assigned IP addresses and the app, and then have the loopback interface. So at the end of our configuration in CE14, we should be able, if we show IP route, right now we're only getting our local routes, but after we've done everything correctly, we should be able to see routes coming in from CE12, and then we should be able to do the same in CE12, where we'll be able to see routes coming in from CE14. So currently we only have local and connected routes, which is okay. So for BGP, our AS number is 65,000. Our MPLS service provider infrastructure, our AS number is 65,000. But for the L3VPN customer, that is a customer, we've given them a name, Amani. Their AS number is 65,100. As you can see, they are sharing that AS number, which tells you that they belong to the same administrative domain. That's good. Okay, so our first step or first task, if you remember, is that we are going to do MPBGP. So let's start configuration of MPBGP, and we start off in Rwanda PE01. You go inside the system view. First of all, let's confirm that we don't have BGP running, and we do not. So let's quickly initiate that. And the command is BGP, then you give your autonomous system number 65,000, and then the command is peer. We are using loopback IP addresses to do the peering, and the reason as to why we're using that is because number one, these particular devices are not directly connected to each other, as you can see from our topology. They're not connected. They're not directly connected, as you can see. So we will not be able to. We will not. It will not be recommended to use the physical connection. And then because we are running IGP inside our MPLS service provider environment, then the loopback interface of PE08 is able to be learned by the Rwanda PE01 device. And in case maybe this particular, assuming this is the route we're using to go to France, in case this link goes down, then we will still be able to learn the loopback interface because there is a other connection. As you can see, we can either use this path or we can either use this path, or assuming that even this part goes down and this part goes down, we still have reachability. We can still be able to trace or ping the loopback IP address of France PE08 because we still have a path to that particular destination. So that's the reason as to why we're using loopback interfaces as our PE to PE BGP peering. So our peer, the loopback interface of France PE08 is 10.8.8. The loopback interface of Rwanda PE01 is 10.1.1.1. And then here we have to give the AS number. Give some space there. AS number. Our AS number is the same. So it's MPBGP, but now it's IBGP. So we are doing, we're using the same AS number. Now, because we're peering using our loopback interface, we have to instruct BGP that the interface that it should use to initiate the connection is not our any physical link or logical link because we're having ether trunks, but it's our loopback interface. Okay, then from there you go inside the IPv4 family contextual help. We have all these multiple IPv4 families that we can choose, but our focus or the interest that we have is VPN v4, so we choose that. Can use unicast or by default is unicast, and then from here we can be able to say peer 10.8.8 enable, and yes, we say yes. From here we can do a commit, exit from here, and we display this, and we can see that's the command or the commands we gave. We did not give this particular command. It is there by default after you enable the PA under the IPv4 family or under the VPN v4 family. So this is the normal IPv4. You can actually go inside here and disable it because we're not going to use it. So you can say undo, then say yes, and then you commit, you quit, display this, and you can see we have undone that particular command. So we are done in Rwanda PE01, which is Huawei. Let's go to France PE08, which is Cisco, and they'll give a similar configuration here. Conftv, the command here is router BGP 65,000. Now we are going to do VPN v4, so we're not going to do the normal IPv4. So we can disable that normal behavior, or because by default IPv4 is enabled. So we disable that by this command. We issue the command no BGP default IPv4 unicast. Then now we can give our command neighbor 10.1.1, which is our loopback IP address of France, no, Rwanda PE01, and then the remote is, because we're in the same company, which means under the same administrative domain, then we use 65,000. So that is MPBGP, but it's MP IBGP, multi-protocol IBGP. And then similar to what we did in Rwanda, here again we give the command update source because we want to instruct BGP that it should use our loopback interface as the source to initiate the connection, because BGP is a TCP connection. So you have to, if you don't give that command, it will not come up, and you'll be stuck. So until and unless you give that command, BGP VPN v4 neighborship won't come up. Then from there we go now into address family VPN v4 unicast, and there we can give the command neighbor. Let's just copy this, neighbor 10.1.1.1 activate, and the moment we give this, we should have a syslog telling us that indeed we have established MPBGP with our Rwanda PE01. BGP can be a bit slow, but there you go. We now have that neighborship coming. That's perfect. So we can exit from here. We can save our configuration, and we can confirm that particular neighborship by this command in Cisco, show BGP VPN v4 unicast all summary, and there you go. You can see that it's up, but we're not getting any prefixes just yet, but this is a good start. So in Rwanda, the command we can quit. The good thing with the Huawei is that you can run almost any command in any view, and you don't have to quit or use, like in Cisco, where you have to give the keyword do in when you're not in the exact user executive mode. But in Huawei, you can do that. You know, we have come back to the system view. So let's give a similar command here to show our neighborship. So display BGP VPN v4. Then the command is VPN instance. No, VPN v4 all here. And as you can see, we are in established state for 1 hour and 1 minute and 31 seconds, and we are not receiving any prefixes. So MPBGP is done. MPBGP is done. What was our next step? Our next step, so we are done with this. This is done and dusted. Our next step is we create customer VRFs on both PEs, and of course be able to attach route distinguisher and route targets on those particular VPN instances. So VPN instance is a term associated with Huawei. VRF is a term that is associated with Cisco, but they mean the same thing. So let's quickly go and do that. So this is done. Now this is our next step. Let's go back to our lab. So we're in Ronda PE. Let's go and define our VPN instance, and the command is IPVP VPN instance. Then you give it a name because it's already, as you can see on your screen, we already have names for these customer devices. So we can go ahead and use Amani. Amani is a Swahili word meaning peace, by the way. So Amani. After that, enter, and then you want to put this under the IPv4 address family. So IPv4 family unicast. Then the next thing is our route distinguisher here. So so you can give your route distinguisher in this format. You either use an IP address, then you give yourself a number in this range, or you could do a number in this range and another number in that range, or of course you have a full colon in between. Or you could do, there's so many options that you can use, but my favorite one that I like using this format where I'm using the loopback interface of the PE and the customer AS number. Okay, so in this case, our route distinguisher will take this format 10.1.1.1, which is our loopback interface in Ronda PE01, and then our customer AS number is 65,100. Okay, that is done. Then the next thing we need to give is our route distinguisher and the command in Huawei, our route target, either for import or export, and the command in Huawei is VPN target. So VPN target, contextual help. Again, you can use the same format, but in here I like distinguishing what our route target is from our route distinguisher. Just when you're doing troubleshooting, you quickly know that this is a route distinguisher and this is route target. So I will choose a different format here, and I will decide to go with the second option of the number. So the first number will be our service provider AS number, which is 65,500, and the second number after the after the full colon will be the customer AS number. So let's do that and say 65,000, and then our customer AS number is 65,100. Now another contextual help here, if this is the same value that you will use for export and import, then go ahead and say both. But if you have a different value for export and import, then you can go and say maybe this is for export, and then you go ahead and give another one for import. But for our purposes here and for simplicity, we're going to use the same route target for exporting and importing. So we can say both. As soon as I hit enter, you get a message that says that has been successful. That's a good thing. And we create and commit. Remember to commit in Cisco. Sorry, in Huawei. Always remember to commit for your commands to take effect. We are done here, and we can issue the command display current configuration VPN instance, and there you go. That's our VPN instance. We give it a name Amani, and another IPv4 family, because you can also have similar configuration for IPv6. That is our route distinguisher, and that is our route target for exporting, and a route target for importing. So we are done doing that in Rwanda. Let's go to France. Conft, the command to define a customer VRF here is VRF definition. and then you give a word. Let's give it a similar word as Amani, as we did in Rwanda, and then address family IPv4, exit. Now here we give a route distinguisher, but instead of the full name here, it's initialized as RD. The similar case, we used the loopback interface of our PE and our AS number. So let's quickly do that, 10.8.8, and our customer AS number is 65,100. And then now we give route target. The command is route target. Here you get to say both before you give the route target, but in Huawei you give the route target then say both. So we are using the same value for both importing and exporting as route target. So route target both, and now we give the number in this particular format where the AS number of our service provider and the AS number of our customer under VRF Amani, and we are done. So end, save our configuration, and quickly we can verify that show run VRF. We only have one, so we just have we're going to get a very brief output. So that is our configuration. As you can see, it is similar to what we did in Rwanda PE. So we've done MPBGP, we have done defined customer VRF or VPN instances. So the next thing is we go into the interface connecting to our customers and put those interfaces to the relevant VRFs. But in this case, we only have one VRF per PE. So we're going to do VRF Amani on both sides. So let's go to, we're in Rwanda, let's complete it here. So let's go to interface Ether 108. Let's see what we have under this interface, what we have configured. We have configured an IP address. Now, if you configure an IP address before assigning an interface to a VRF, that configuration will be deleted. So it's always good to check before you go ahead and do bind that interface to a VRF. So the command to do that in Huawei would be IP binding, and then of course VPN instance keyword. Then if you see in the list, you only have Amani. So once you do that, you get this particular message here that the configuration on that particular interface are removed the moment you issue this command. And if we can just commit and we display this, you can say indeed our IP address has gone. So let us reissue this command the way it is, and then we commit, display this. We are good here. So this particular interface has been assigned to the customer VRF, and it is no longer in the global table. If you say display IP routing table here, you will not see it. You will not see 192.168.112.1. It's not here. But if you say display IP routing table for VPN instance Amani, then you will be able to see that particular IP address right there. This is the broadcast right there. That's the IP address that we are focusing on. That is the prefix. We are good, and it clearly tells you that it is assigned to that particular interface there. Okay, so can we ping our customer? And again, we have to ping inside the VRF. So ping VPN instance Amani, and then we issue this particular IP address. First of all, let's ping ourselves. Perfect. Yes, we can. Let's ping our customer. That is 12. Brilliant. That's good. That's very good. Let's go and do the same in France. Conft interface gig 5 is the one that connects to our CA14 in France. Before we do the binding, let's just before we assign this particular interface to VRF Amani, let's just see what configurations we did. So do show run interface gig 5. yeah, we have an IP address here, so let's go ahead and do. So in Rwanda, the command we issued was IP binding, but in then that VPN instance keyword, then the VPN instance that we had defined. So in Cisco, the keyword to do a similar task would be VRF forwarding, and then you give the VRF. Once you do that, you can see again similar to what you did you saw in Huawei. Even in Cisco, you get that particular message that the IPv4 that you had given or you had configured earlier um, and are removed due to enabling VRF command. This just tells you that the reason as to why they have been removed. So if we can actually go and confirm that IP address is gone, but the interface is under VRF Amani, that's good. So let's go and copy this IP here and reissue it again. Ensure it's not shut down. It's not shut down. Is it? It's not. And let's confirm now that indeed all is good. That's fine. Perfect. Similarly here, let's say our global routing table, show IP route. This is our global routing table, and we cannot see 192 anywhere here because that interface is no longer in a global routing table, but the interface is assigned to the VRF or virtual routing forwarding table of our customer Amani. So to show those routes under the VRF, the command is show IP route VRF Amani. Ensure that the name you give is case sensitive, so it has to be exactly the way you defined it. So that's where you're getting to see our prefix, and this is of course what we have configured. The local L means local, C means connection. So this is what we have configured for this interface. And can we ping VRF Amani? Then the IP address. Let's ping ourselves first. We can ping ourselves. Now let's ping our CE, which is .14. Yeah, we can ping ourselves. So the first one is dropping because of the app that has to happen before you can see reply. So if you just reissue it again, and you can see we are doing very, very well. So we have done MPBGP, we have created VRFs, we have assigned those VRFs under interfaces. Now what is done? What is not done is now to do the PE to CE peering, and we're doing BGP. So because we're in France already, we're in our service provider environment, let's go ahead and do now PE to CE peering and use BGP. So let's go to conft. Let's first of all do show run section BGP. This is what we have configured under our BGP. So we take this and we say now the address family is IPv4, but this is for our PE to PE peering. Now for us to pair with our CE14, we have to initiate another instance under BGP, but now the address family will be an IPv4, but for that particular VRF. And this is how you do it in Cisco. The address family IPv4 unicast, and then contextual help, you can see this VRF. Then you go ahead, VRF. Then you go ahead and give the VRF name, and for our case, the VRF name is Amani. So we are under this particular address family. So here we can issue the command neighbor. And who is our neighbor? This is our neighbor here. The IP address here is 192. 192.168.148.14. And then the remote S is 65,100. All right. And then we can actually say maybe activate, and then maybe give this command here soft reconfiguration inbound, so that I should be able to issue the command and see what routes I'm advertising and receiving. from our CE. So we are done that configuration. So let's go to CE14 and do BGP, or initiate the BGP process. Conf T, do show run section BGP. We don't have BGP here, so let's start that. So router BGP 65,000 is our autonomous system number. 65,100. Sorry. Yes. Then no BGP. Well, there's no need to disable this here because we are going to do the normal IPv4, which is enabled by default. But assuming you want to do IPv6 later, so let's go ahead and disable the behavior. No BGP, default IPv4, and then neighbor 192.168.148.8. He is in remote 65,000. And once you do that, you say address family IPv4 unicast, enable that neighbor by this command, activate. Perfect. We should have a message, a syslog that we are good, and soft reconfiguration inbound. Good. As you can see, we have a message that we have formed neighborship. If you go to France, it will tell you that we have formed neighborship with this particular IP address, which is a virtual private network under VRF Amani. So that's good. So since we are here in C14, let's advertise our networks. And the network we want to advertise, number one, is that direct connection between our PE, and that network is a /24. So mask 255.255. But if you don't give this one here, it will pick because of the classless interdomain, routing CIDR. But let's just do it. If I give this command, it will accept it. But I will be able to show you that it was not necessary. And then another network is to show run interface loopback 0. That is a the subnet is 24 again. So, but this one here we'll have to do the mask definitely. So network. This is how you advertise your networks, by the and ensure that you do it correctly. And then the mask is 24-bit subnet mask. So let's quickly confirm what we've done. Do show run section BGP. Okay, you see, we gave this particular command with the mask, but in the output you only get to see that prefix. Okay, but for the 10.14.14.0, the mask that we gave, that command is intact. So again, that is subnetting 101. I'm not going to dive into that particular one. So, and right, let's go back to France. We are still under our IPv4 address family for verifamani. And also here we give the command, we also advertise the network, this particular network that is connecting to our CE14, 192.168.148.0. Okay, do right. We are done there because as you can see, show BGP IPv4 unicast. You can see we are good here. You can give command summary. We are getting one prefix from our France PE. That prefix is actually here, which is that network that connects our PE and our CE. So we're done in France. Let's go to Rwanda. Rwanda, let's quickly see what we have under BGP. Display current configuration BGP. That's good. So let's go back in here, and we give a similar command. So we are going to initiate BGP between our CE, and the command is IPv4 family contextual help. We're going to do VPN instance Amani. Okay, and here we give the command peer. Who is our peer? Our peer is 312, which is 192 is 196 168 112.12 is the peer address, and then this particular guy here is in AS number 65,100. Okay, we can issue the command network here, so we give this particular guy here as the network and we commit. Let's go and do configuration in to show run section BGP. It's not there, so let's initiate it. Router BGP 65,000, no BGP default. I can just leave it just for demonstration purposes. It will still come up. So if the command neighbor 192.168.1, remote AS is 65,000. Should have a neighborship come up. So network peer in wrong AS. This is good for troubleshooting. Peer in wrong AS. So what did you give here as a peer? Display this. $65,100. Display current configuration BGP. Let's quickly troubleshoot, guys, and see what is going on here. Okay. Aha, we gave the wrong command. So let's remove this. Let's remove this. It's supposed to be. Let's give this as the command. Now it should come up. So network. The network we're advertising is this particular network here, .0. And then to show there seems to be a problem. There seems to be a problem. Why are we getting this problem? Let's remove that and see what's going on here. Okay. Yeah, I see where the problem was. I think we had given this one here as GP65. Yeah, that's where the problem is. This is the problem. So let's go back in here and do it quickly. Router BGP65,100. Now neighbor 192.168.112.1. Remote AS 65,000. It should come up now. Good, there we go. Perfect. So network, then to show IP interface brief. Our back interface is a /24. So give command network 0 mask 255.255.255.0. Right. To save show IP BGP, or you can even say show BGP IPv4 unicast. There you go. No summary, sorry, summary. All right, guys. Let's see the routing table. Show IP route. But I can tell right now there's something that is not configured, which I did by purpose, on purpose. So as you can see, in CE12, I'm only getting this route via BGP, which is this particular link here. But I'm not getting the loopback interface of CE14. Okay. So let's go and examine the routing table of CE14. First of all, let's see what we're getting. Two prefixes. Which one is that? So in here, I am getting again this particular prefix here. Okay, but I'm not getting the loopback. And the reason is very simple. The reason is very, very simple. Why are we not getting the loopback interfaces? For example, C14 is not getting the loopback interface of C12 and vice versa. It's because they are using the same AS number. And if you remember, for eBGP or BGP, if I see an update that is coming into me with the same AS number as myself, then I discard that update. I'm not going to install that particular route in my BGP routing table, and therefore it can't be also installed in the global routing table for this customer C14 and C12, that is. So the solution can be done from the customer end or from the PE end. From the customer end, you issue the command. You go to a BGP process and issue the command neighbor, for example. Let's say conft router BGP 65100. Do show run. You issue the command neighbor, this neighbor here, but that's under the address family IPv4. Then the command is neighbor AS override. You issue that command for Cisco, but I'm not going to do that here because I want to show you how you can do it in Cisco and Huawei. Okay, so let's save our configuration. Let's go to Cisco. So Cisco, we are still under the address family for our VP, our virtual private network verify money. Okay, do show run section BGP. So we are still under here. So what you do, sorry about that, guys. Sorry about that. So what you do is you go to your neighbor, that is 14, and then you issue the command instead of AS override. No, actually that was wrong. Sorry, guys. I'm giving you the wrong command. The command is where this is where you're supposed to do AS override, but over here in the CE router conft, this is where you're supposed to do allow AS in. That's the command I wanted to show you, not the other one. Go to it, neighbor, allow address family IPv4. Then you say neighbor, allow AS. in. That's the command that we would give in Cisco. But I want to do it from the PE side so we can see. So the command here is AS override. If we could quickly show you the entire output again. Again, I apologize for misleading you early. So that's the command right there. Let's see if anything changes when you do show IP BGP. And as you can see, we're getting 12 here. But earlier on, we were not able to get 12. You can see we were not able to get 12. We're only getting this physical interface connecting to connecting C12 and PE01 in Rwanda. But now, after we issue the command, we're going to get that particular prefix. And if you see the routing table, show IP route BGP, you can see we've now installed that route in our routing table. But for CE12, it's still not fixed. It's still not fixed. We have to fix it in Rwanda PE01. And we are under Amani IPv4 family VPN instance for Amani. This is where we do it, and we can issue the command say peer our peer, and then in Huawei the command is substitute s, and then you commit. Give it a few minutes. Give it a few minutes, and then you can go and check again in perfect. So we are having that route here. Now that is the route. Where is it? Here. We are getting that prefix installed after we've given those commands. So we are done. What is left is actually doing configuration, because show our IP route BGP gives us all that we need to have as a prefix. So the first verification to do is, can we ping the loopback interface of C14? The answer is big yes. So can we trace, so that we can get to examine the path that we are taking? So what path are we taking to go to CE14 in Rwanda from CE14 in France from CE12 in Rwanda? So it goes to your gateway, that is 1. So it comes like this. Traffic comes this way, and then it goes to 10.4.17.7. It comes this way, and then it goes to, so it uses this route. Then it goes to 148.8 here before it goes to the CE. So let's see the return traffic. Ping 12, 10.12.12.12. We can ping. Can we trace, so that we can be able to examine the path? Good. So for the return traffic, for our return traffic, it's again, for this case, it's using the same path. So it's coming from this guy here, goes to 8, and then it uses this 10.4.7.8.7, this interface here. Then it goes this way before it goes to our C14. Now we're not able to see 10.4.17 in our output. I'm not sure if that is because of the lab environment that we are in, but ideally we can confirm, or I can comfortably tell you that the route that we're using to go from C12 to 14 and back is the same one. So that's because we have not configured any traffic engineering. So there are pre-configured LSPs, and according to our ISIS, which is our IDP, the best LSP has been established, or has been chosen for us by ISIS, and it has said that for inbound and outbound traffic, that is the route that we are supposed to be using. So guys, that is how you configure. That's how you configure basic MPLS L3VPN in Cisco and Huawei devices. And you can see we have full connectivity, and our and our configuration has been successful. And now the next video which we'll be producing now, we will be configuring L3VPN. After we're done doing L3VPN, we can now come and do traffic engineering, where we will be able, for example, to say, for this particular customer CE12 going to France, I would want this particular traffic to come this way. Just for the purposes of this illustration, we would want to influence traffic in that manner. And then for the return traffic, what we will do, because you can see it is using like you said, the bundle or the physical interfaces here are 1 gig. So if you bundle them together, this gives you 2 gig, gives you 2 gig, it gives you 2 gig, it gives you 2 gig, 2 gig, 2 gig, 2 gig. But you can see our traffic is choosing a path that is not 2 gig. It's choosing this path, which is 1 gig, because IGPs don't care about bandwidth capacity. As long as this is the shortest cost path, it will take that one. But we don't want to have that kind of scenario. We want to be able to influence our own traffic. So what we will do is that for traffic from C12 to C14, meaning from Rwanda to France, we'll use that red route. And for the return traffic, we can influence it to use, of course, it will hit PE08 because that is our only exit or entry to our MPLS service provider network. And then it can still use the same path. And then instead of going to Kenya Mombasa P07, I want it to use this path and finally exit out. And that is only possible with MPLS traffic engineering. But that will have to wait, because our next video will be dealing with L3VPN, specifically this guy here and this guy. Again, he is in Rwanda, he is in France. I want them to communicate with each other using our service provider environment. That has been our time. Thank you so much for watching this video. In case of any comments, any question that you would like to ask, or if there's something that is not very clear, or there's something I said that you disagree with, again, feel free to share that in our comment section, and we'll be happy to answer those or reply to questions or see your comments. And see you next time. Keep safe and bye.